Look at any busy market street in India, and you'll see a constant physical exchange of currency. Millions of transactions happen every hour, subjecting these banknotes to friction, sweat, folding, and extreme heat. We call this money paper, but traditional wood pulp paper would instantly disintegrate in this environment. It would absorb moisture and lose its structural integrity within days of entering circulation. To keep the economy moving, the Reserve Bank of India treats currency production as a high-security manufacturing operation, producing billions of highly durable technological devices. Surviving the friction of a billion-person economy requires engineering a unique material, built up precisely from the cellular level. The lifespan of a banknote begins in the soil. The core material is grown and cultivated in massive fields, yielding the specific, long cotton fibers required for production. These premium cotton fibers are sorted by length and strength, then blended in carefully controlled proportions with specially selected linen. This creates a specific, proprietary cellulose composite. This chart shows exactly why that blend is crucial. The structural failure point for standard paper drops off rapidly under tension. The cellulose composite maintains a smooth stress curve, significantly extending its folding endurance under mechanical pressure. Before a single drop of ink touches the surface, the blank note is already an ultra-durable, rigorously tested fabric. Inside massive industrial vats, powerful refiners mix cotton and linen fibers with purified water, breaking them down into a uniform, violently churning slurry. This wet stage is where the first layer of anti-counterfeiting security is integrated. The metallic security thread is fed directly into the paper while it is still entirely liquid. The iconic Gandhi watermark is physically sculpted into the substrate. As the wet paper forms, specialized cylinders vary the actual thickness of the pulp to create the portrait within the material itself. Manufacturing tolerances are incredibly tight. 33 laser sensors constantly verify the exact sub-millimeter position of every security thread while the paper is still drying. The resulting base substrate is a complex three-dimensional security matrix. Standard commercial printers cannot reverse engineer a structure that is embedded inside the material. Once dry, they enter massive offset presses to receive their first layer of multicolor printing. This lays down the intricate visual foundation of the banknote. The true security here is chemical. Secure laboratories formulate proprietary fluorescent inks and specialized anti-counterfeit background patterns that remain invisible under normal light. High-speed registration cameras monitor the presses in real time, ensuring every microscopic color layer aligns perfectly across the entire sheet. This strict alignment creates a visual baseline. Any slight color bleed or misalignment immediately identifies a note produced on unauthorized equipment. Next comes the intaglio printing phase. Enormous physical pressure is applied to the sheets, forcing raised ink onto the surface of every note. This heavy texture serves a practical purpose. The raised denomination numerals and identification marks allow visually impaired users to recognize the value of the currency by touch. The intaglio presses also operate with enough precision to print 17 distinct language panels onto a single note, so cleanly that every character is legible. This microscopic view compares genuine microtext against a counterfeit attempt. On the left, the laser-engraved microtext maintains crisp, clean vector lines. On the right, commercial scanning hardware fails to resolve the detail, resulting in blurry pixelation. In the final quality control stage, 72 unique serial numbers are added to every sheet. High-speed optical systems scan both sides simultaneously, rejecting any section with a microscopic defect. This facility mass-produces billions of physical units while maintaining an absolute zero tolerance for microscopic errors. Only fully approved notes continue to packaging. Each bundle is shrink-wrapped, electronically weighed to confirm the exact quantity, and dispatched in GPS-tracked convoys. The currency finally enters the national economy, moving through automated tellers and cash registers, surviving the friction and environmental stress it was engineered to withstand. Throughout this circulation, the embedded technology remains active. Automated cash handling machines and ATMs read the magnetic threads and UV markers, authenticating genuine notes in milliseconds. The agricultural preparation and complex engineering successfully protect the national economy by catching fraud at every automated checkpoint. Eventually, even these durable notes show signs of wear. When they do, banks rotate them out of circulation, verify them electronically against manifests, and mark them for destruction. Inside secure recycling facilities, the final destruction protocol is executed. The retired banknotes are shredded into thousands of tiny, unrecognizable shreds, ensuring they can never be reconstructed. The cycle continues through research and development. Engineers analyze returned counterfeit attempts to optimize new cellulose composites and sharper intaglio inks for future production. From raw cotton to final destruction, the life of a rupee is defined by constant technological iteration, ensuring the physical currency remains as resilient as the economy it powers.